you think it's adequate? I think it's recording.
For our experiment, we chose to test a different number of dates for our crust to determine the correct consistency.
This is our procedure.
Our hypothesis was, we believe that the consistency of the crust of our lemon bars is dependent on the number of dates used to make the crust. We believe that the more dates used, the chewier the crust will be. Our procedure. Number 1. Follow the recipe exactly using 3/4 a cup of dates tightly packed, which will be our control. Number 2. Blend the dates with the dry ingredients. Number 3. Put 1 inch of the crust evenly spread into a small baking pan. Number 4. Bake for 20 minutes at 350 degrees. Step 5. Repeat steps 2 through 4 for Trial A, a crust with 1 cup of dates tightly packed, and Trial B, a crust with 1/2 a cup of dates tightly packed.
Okay, number 6. You pour the lemon custard topping evenly on top of each of the 3 trial crusts, and then you bake the 3 trials for 20 minutes. You let the lemon bars sit for 20 minutes to cool, and then we're going to make observations on the different appearances and textures of the different crusts.
This is trial A of our experiment. We used 1 cup of tightly packed dates to make the batter. Okay,
Start over. So this is trial A, and we used 1 cup of dates just for the sake of the experiment because we knew that we needed less dates, but we wanted to see what the batter would be like with more dates, knowing that it would be too chewy. However, we did it for the sake of science, and now we're gonna taste them.
And for our experiment, to be consistent, we still used 1 inch thick of batter, even though we knew that for our lemon bars, for our final experiment, or for our final products, we don't want to use that much crust.
But now we're gonna test them. It's gonna be so bad. Like gum.
The second part of our experiment, trial B, we only used 1/2 a cup of dates for our batter. Now I'll put it into the tin.
Wait, I think I date my teeth. In our third trial, we used 1/2 a cup of dates, which we thought would make the batter for the crust the perfect consistency because our other previous trials, we had used 3/4 a cup and 1 cup, and the batter had been too doughy and like chewy, and we wanted it to be more crumbly and dry, so we used less dates.
For the sake of the experiment, we still used 1 inch of batter, so it is still very thick. See,
It's still a little bit too thick,
it's still too thick, but you don't taste
the dates,
as much dates.
and it doesn't make you like want to throw
And it
up.
doesn't like solidify in your mouth. Oh god, we cannot put that in the video. This is our control batch. To make sure that the batter was 1 inch thick in the pan, we also measured 1 inch on a toothpick. Perfect. Okay, taste test number 3.
For your enjoyment, not ours.
Oh my god, and I got the corner that time. Specific heat of a substance is the quantity of heat required to change the temperature of 1 gram of the substance by 1 degree Celsius. The heating curve of water is a property that explains that boiling water will remain at its boiling point of 100 degrees Celsius until all the water has evaporated. The temperature will not increase even if the amount of heat applied is increased. Water has a specific heat of 4.184 joules per degrees Celsius, which is relatively high compared to the specific heats of metals, which are mainly less than 1 joule by degrees Celsius. This means that it takes more heat applied to the water to increase the temperature of 1 gram by 1 degree Celsius. The heating curve of water explains why when boiling water, evaporation will occur at a constant rate because once 100 degrees Celsius is reached, the temperature of the water will not increase anymore, and the rate of evaporation, which is the gaseous molecules breaking away from the water, will not increase. Water has a high specific heat, so when boiling water, a lot of heat is needed to change the water's temperature. As we boiled the water with the cashews still inside the water, the cashews also heated up and were most likely much hotter than the water itself because they have a lower specific heat. Even with the same amount of heat being applied to the water and the cashews, there is a greater temperature change for the cashews because it takes less heat in the form of thermal energy to increase the cashew's temperature than it does the water. This means that as constant heat was applied to the water's temperature remained constant at 100 degrees Celsius, its boiling point, because of the water's heating curve, but the cashew temperature increased because it has a lower specific heat than water, and the cashews have a higher boiling point than water and had not yet reached this boiling point. In our first trial, we left the cashews in the boiling water uncovered on the heated stovetop for 1 hour. From this, we saw that once the water had completely evaporated, the cashews were left in the pan with heat still being applied through the stovetop. And because the cashews were already at a very high temperature, they burned in a chemical combustion reaction. A chemical change will be because of a chemical reaction and will result in a completely new substance. A physical change is only a change in the appearance of the original substance. Physical changes can be changing states of matter or changing the appearance of the substance, but a chemical change must change the chemical properties of the original substance, creating a new substance, even though during chemical changes the state of matter can remain the same. Boiling the water, causing it to evaporate, was a physical change because the gaseous water vapor still had the chemical properties of the liquid water. Water evaporation is the process of turning from a liquid state to a gaseous state because as heat is applied to the water and the water reaches its boiling point at 100 degrees Celsius, the temperature is equal to the pressure surrounding it and there is enough thermal energy present for the molecules to break free into the gaseous state. Clear evidence of the physical change of boiling water is the rise of gaseous bubbles to the top of the liquid. As boiling continues, more molecules are converted to the gaseous state as the heat is constantly applied, providing that thermal energy that is needed until complete evaporation occurs. Once this complete evaporation had occurred, the cashews were left exposed to the heat at the bottom of the pan and underwent a chemical reaction when they burned and formed a new substance at the bottom of the pan. This chemical reaction created a new substance because as the heat or thermal energy was applied to the cashews, they began to react with the surrounding oxygen and evaporated water and creating a new substance. This chemical reaction resulted in a chemical change which we can see because the leftover burnt ash substance at the bottom of the pan does not have the same properties of the original cashews and cannot be used in our recipe.
A traditional egg contains a protein called ovalbumin and is found in the albumin, which is the translucent white part of the egg. Ovalbumin, when exposed to heat, expands and joins with other proteins to create a structure that holds food together. The traditional egg can also be used as an emulsifier, meaning that it is a molecule that has a hydrophobic and hygroscopic side. These properties help to mix water and oil. A flax egg, which is the kind of egg that we used, uses the outer layer of flax seeds, known as the epiderm, and those contain a material known as mucilage that can be drawn out to create flax gel. To make a flax egg, flax seeds are placed into water and are left to sit in the fridge for 15 minutes. After 15 minutes, the flax gel has been drawn out and the egg is ready. Flax gel is a hydrocolloid, which means that it is a substance that when combined with water forms a gel. Hydrocolloids are made up of polysaccharides, which is a type of starch. These starch molecules have the ability to form a structure and act as an emulsifier like a traditional egg. How we used it is we used it as a substitute egg to make the crust, and we had to let it sit and solidify so it would be the consistency of a real egg. We didn't use a real egg because Margaret is vegan, and every morning Miss Ella thought it would be interesting if we told you that Margaret has a flaxseed smoothie, and if she lets it sit for too long it turns into like jello. Microwaves are a type of electromagnetic radiation that are used for communication, radar, and cooking. Electromagnetic radiation is transmitted in waves on different wavelengths and frequencies, and it makes up the electromagnetic spectrum. On the spectrum, microwaves fall between radio waves and infrared waves. Microwaves can be used to transmit thermal energy, which is necessary to heat food. In a microwave oven, a device called a magnetron generates microwaves which heat foods. The magnetron uses the power that is drawn from an outlet in the wall and converts it into 12-centimeter microwaves. The microwaves travel through the food and cause the molecules of the food to vibrate, which in turn releases thermal energy and heats the food. In our recipe, 5 tablespoons of melted coconut oil are required to help make the dry ingredients and dates into a consistent batter for the crust. We microwave the coconut oil for 30 seconds and it melts from a solid state into a liquid state because of the microwaves.
The chemical change between an amino acid and a sugar that requires a source of heat. It can also be called non-enzymatic browning reactions because it causes dough or breads to brown. The Maillard reaction is a chemical reaction between an amino acid and a sugar that requires the presence of heat in order to begin. The Maillard reaction is present in most baking recipes, and it is affected by many factors that explain the finished product. For example, the Maillard reaction is dependent on temperature, pH, and moisture within the baked substance. When the temperature or time of exposure to heat is changed, there are different results in the final product, which explains the difference in something that is baked for a long time, where the browning will continuously occur, and something that is baked for a shorter period of time, where there will be less browning, because the Maillard reaction did not happen as many times, because the substance was not exposed to heat for as long. We used baking to solidify the crust of our lemon bars, so that they would have a solid structure when taken out of the pan. The Maillard reaction explains why the ingredients of the dough reacted with each other and formed the hardened brown crust of our final product after being baked. Recipes with milk will result in a darker crust color because there are many amino acids in milk, which allow for the Maillard reaction to repeatedly occur with all of these amino acids. Connected to that, our recipe lacked milk. Thus, the amino acids that were part of the Maillard reaction in our recipe came from the dates used in the crust. Dates are not as rich in protein as milk and amino acids, so our crust was not as dark as a regular crust that would have milk in it. Acidity is the level of acid in a substance. An acid is a chemical substance whose properties include a sour taste, an ability to dissolve many metals, and the ability to turn blue litmus paper red. In acid-base reactions, acid will give off H+ ions, and the bases will receive these H+ ions. Acids react with bases in neutralization reactions that produce a salt, which is an ionic compound, in water. Marble is composed of mainly calcite or calcium carbonate, CaCO3, which is a basic inorganic salt that is commonly used as an antacid to neutralize HCl in human gastric systems. Lemon juice is composed of mainly citric acid, which is a relatively strong acid with a pH of around 2. The calcium carbonate in the marble will react with the acidic lemon juice and will result in a neutralization reaction where the acid will be the limiting reactant because there is excess marble in the countertop. Calcium carbonate is also slightly soluble, thus, when the reaction occurs, the acid reacting with the marble will cause the dissolution of the marble. Dissolution of marble is commonly referred to as marble etching because it changes the surface of the marble from smooth and shiny to a rough, non-shiny texture. When cooking, you should never squeeze or handle acidic foods on marble countertops because marble is composed of basic compounds that can react with the acidity in the lemon, causing the marble to deteriorate as the acid-base reaction occurs. For our purposes, we avoided handling the lemons used in our custard on top on the marble, but this also applies to acidic food and drink like oranges or wine.
The definition of density, is mass per given volume. When you have two liquid substances with different densities contained together, the less dense substance tends to float on top of the denser substance because in the less dense substance, there is less mass per volume. In the coconut cream that appears at the top of a coconut milk can, it is less dense than the milk itself because it has less mass per volume, which allows it to sit on top of the coconut milk. The molecules in coconut cream are mainly saturated fats, which have less mass per volume than the protein that is present in coconut milk. The recipe calls for the use of coconut cream in the lemon custard, which means that because of the different densities of the cream and the milk, the coconut cream remains at the top and is easily extracted for our recipe. The molecule is formed with polar bonds that do not cancel each other's charges and form a net dipole moment. A molecule's polarity is determined by its molecular structure. The charges are determined by lone pairs in an atom's Lewis structure, and so when a molecule is polar, it has a positive end and a negative end, and when a molecule has no positive or negative ends, it's nonpolar. When a nonpolar solution and a polar solution are mixed, they will separate because they repel each other. This is because the two liquids must be of the same polarity, nonpolar and nonpolar, or polar and polar, to be miscible, which means they have the ability to mix. Oil-based substances, which are nonpolar, and water-based substances, which are polar, can be mixed, but eventually will separate again. In its original state, canned coconut milk is made up of the coconut cream and coconut milk mixed together. Our recipe for the lemon custard calls for the use of coconut cream. Coconut cream is found at the top of a can of coconut milk because it contains oils that make it nonpolar. The coconut milk at the bottom of the can is polar, which causes the cream to separate into coconut milk and coconut cream. The cream is used to make the custard topping more homogeneous.
Right.
Start over.
Okay, ready? You can't talk right now. Well, let's see how this...
This is more interesting.
Okay, shh. Everybody be quiet.
And more?
Into this thickly... Oh my god, what am I saying?